Welcome everyone to our webinar today on ProVIEW, teaching about smart materials and some of the exciting things going on in this important marketplace. I'm Ed Nabrodsky. I'm the Chief Solutions Officer here at Omni-ID, responsible for a lot of the product road mapping and working with our very largest customers on their implementations as we pioneer this new technology and change the face of manufacturing. We're grateful to take a little bit of time with us today. We're going to go through a pretty simple agenda. Our agenda will cover a little bit about industrial IoT and Industry 4.0, as we talk about it quite often in Europe, driving some of these new technologies, explaining what ProVIEW is in that context, and then going through some of the canonical material flow management applications that ProVIEW covers and that are certainly of concern to many of the audience here who are listening in today. We'll share a little bit of the journey of some customers to talk about their success stories, as that's one of the ways I know we all learn, and so we'll relay what we can on a few good examples. And then we'll host some Q&A. Throughout the session, I encourage you to listen, of course, actively. Take notes as you go. We won't pause for questions through the actual slide deck, but at the end, we'll be monitoring the chat board. So if you'd like to put some questions in real time as you're thinking of them, or hit us with all of them at the end, either one will work. We'll try and answer questions live here during the session. Any question we don't get to, we will send some emails afterwards to make sure your question is answered. So please make sure you log something on the chat room side, and we'll make sure we get back to it. So first, let's talk a little bit about who Omni-ID is. Omni-ID really has two businesses, and many of you on this call may know us for our industrial asset tags. We were the first company to promote on-metal RFID. All of our foundational patents have been licensed to many other players in the marketplace, so pretty much any on-metal RFID tag that you see is built on the foundational technology that Omni-ID initially built with our plasmatic structures and our ability to function on that metallic and liquid surface. That's still a huge part of our business, and we do tagging projects all over the world, getting involved in many, many things across many different sectors. But over the last several years, we've been growing another business called ProVIEW, and our ProVIEW solutions is focused very much on the manufacturing marketplace and trying to get a deep dive into how to assist in the material flow on a plant floor. And we'll talk about that in detail on this webinar today. So really the right side of this diagram is where we're going and where we're going to talk about today as we build industrial IoT solutions for manufacturing. Another key thing to know about Omni-ID, if you didn't know this about us, you probably should. We are a global company, operations on all the major continents around the world. I'm broadcasting today from our Rochester, New York headquarters. We also have an important sales and support office in Detroit with many of our customers there. In Europe, we do a lot of our RF design and our key scientists for materials out of the UK, just outside of London in Farnham. And we also have a sales and support office in Germany as well, in Cologne. India, sales and development offices in Mumbai and Bangalore, respectively. Our main manufacturing center is in China, although we do some manufacturing in some of the other sites. But obviously, by far, our major volume comes through our Chinese factory, and then also our in-country sales office in Shanghai that services our Chinese customers directly in country. So we're able to support you all over the world. If you are a manufacturer of goods and you have plants in different places or end customers in different places, these core offices of Omni-ID support over 500 different integration partners around the world. Wherever you are, we can support your project, and we're doing that now for many of our Fortune 100 enterprise class customers. I mentioned a little bit about our business model, and I want to talk in the next slide a little bit about how that works by vertical. So Omni-ID is installed in almost every vertical you can imagine, but that really comes to our EAM tagging business. The EAM tagging business is our harsh industrial tags that we're well known for, and we have them in healthcare, oil and gas, many government and defense projects, IT data centers, and many, many others. We work with our list of hundreds of partners around the world to make those applications happen. And in those cases, we're a very active partner, helping to solve problems, but we're usually not front and center on the program. Our partners do a great job on supporting those applications with domain expertise. The place that we've decided to become very good at is our manufacturing logistics business. And over the last several years, our hiring has been in this area, our expertise has grown in this area, our engagement with customers has grown to where we have a fully integrated vertical solution set for manufacturing and logistics. We offer professional services and support, software, and of course the tagging that can support everything that has to happen inside a manufacturing plant. We still work with many partners in this area to help us with installations, with support, with drivers, with back-end systems, but we take a much more active role in manufacturing logistics and focus our ProVIEW solution directly on that vertical. Now, let's talk about manufacturing, which is that area of focus that we've just discussed. As we talk about IoT, and especially industrial IoT, the focus here is on the container. There's over 550 million returnable containers cycling daily around this planet. Those containers are carrying everything from car parts to dental supplies to chemicals to semiconductor chips. Almost every industry uses some form of returnable container to move their goods around their factories and around their supply chains. This is the natural place to focus our attention in IoT. Many materials are very difficult to alter. Some are far too small to put intelligence into them, but the container is a natural place to make intelligent and to be part of the system. So on the committees I work on, as we're developing standards and talking about IoT and what can happen, there's a lot of focus on the container as being the key to making materials smart. And that's where we're at. Our next slide shows you a little bit of what's happening in the industry. So I mentioned that I work on a lot of different boards and speak at different events in manufacturing. The manufacturing world is changing dramatically. And if you're involved in it, you know that already. In the 70s, we had a major revolution when we became aware in this country especially that the Japanese automakers were doing something different than we were. They were able to be more efficient. They were able to produce higher quality. And a lot of consultants were paid a lot of money to figure out the Toyota production system and to reincarnate it into different versions, whether it was Lean or Six Sigma or just Kanban or TPS. We really reinvented manufacturing in the 70s. But that was still built on a model where a plant was set up and it would mass produce one thing continuously for a period of time, sometimes 5 years before you did a model change out. And those systems of paper Kanban labels or poke-yoke processes were very efficient for that kind of a flow. Plant managers today are under different kinds of pressure. They're no longer building one thing for 5 years on their line. They're building multiple variations of the same thing. They're retooling their line every 6 months. They're putting in new features. And more importantly, their customers are demanding full transparency into the plant. If their customer buys a particular car, they want to be able to show that car being built on the line. They want to show suppliers to do vendor-managed inventory exactly how many more pieces of purple shag carpet they need on the line tomorrow with transparency directly to the line to fulfill the efficiency model. The models are more complex, the supply chain is more complex, and the demand for transparency is overwhelming. Paper simply can't keep up, and the methods of the 70s are not going to be effective as we tackle this IoT world of cobots and demanding customers and demand triggers coming in from internet triggers. So something has to change, and that's really why ProVIEW was born. To put a finer point on it, you can think of the plant in this way. You have your inputs to the plant, a bunch of parts that come in and get stored in a warehouse when they come in through your receiving dock. And you have an output where at your shipping dock, you're loading your output onto trains or trucks and shipping that to your end customers. In between that, to put it crudely, most of the systems today generate a hunk of paper and tell workers, I need to build this thing, and then tribal knowledge takes it through the plant for that widget to be built. That is not effective when you have a high mix and high complex environment, and especially when you're demanding transparency, to be able to look into that black hole cloud and find out exactly where any piece of material is at any given time and know what state it's in, whether it needs to be replenished, whether it needs to be changed out, whether I have enough of it, or whether I need to do an upstream demand trigger to get parts in my warehouse. So that piece of paper that has been traveling around and the tribal knowledge of the workers that are making it all happen now needs to be framed in an IoT perspective to create the right kind of system that can be effective. And that's what we're talking about today. So the IoT goal, industrial IoT goal, is that the object be sensing and signaling its location. And IoT, of course, Internet of Things, means that the thing becomes smart and can now talk to different things around it, specifically up through the internet, but also to talk and interact between other bots or other machine items. This means that a smart material or a smart container should be able to talk to the humans in the process by means of visual signaling, like the screen you're seeing, and talk to machines by means of wireless communications, being able to exchange messages saying, paint me blue, put me on this pallet. Those signals in both directions are really key and are key goals of industrial IoT. Another key goal is decentralization reliability. If you're a plant manager on this call, as I have been before, I've had many people come and pitch me very complicated systems with all sorts of highly customized and configurable software, lots of specific wiring with I/O blocks and things that have to be set up, and it's a nightmare to try and reconfigure it. That was okay in the old days when you never reconfigured, or you reconfigured on a 3-year or a 5-year basis, and you're able to run your plant continuously before you had to bring in the engineers and retool a line. Sometimes those retooling of the lines took months, and you were shut down while you did that. That can't happen in today's highly configurable environment. And that's why one of the IoT goals is decentralization and reliability, the ability for things to be smart enough to be reconfigured easily, to be able to spread the decision-making down to the material, enables a whole new paradigm. No more lying down for 6 months while I retool. How about if I retool every hour and I can reset my lines? How about if I'm like Amazon, I put everything on wheels and everything moves in a coordinated dance, talking to each other based on a demand trigger? Those kinds of paradigms are what the C-level executives are thinking about today in our top manufacturing customers, and they need the kinds of systems that will enable that. Mobile, intelligent, decentralized systems where you don't need to pre-program and pre-configure and have an army of IT people monitoring it and setting it up, but have this decentralized intelligence at the material to be smart enough to know what it's supposed to do and be easily reconfigured as they talk to each other and know what they have to do next. So that goal of decentralization reliability is very key. The next goal of aggregation is important. You're hearing in IoT speak people talking about billions of devices being connected to the internet, on the order of 20 to 25 billion devices in this next few years. That creates a huge problem from an IT perspective and a data perspective. Autonomous cars by 2025 are going to be on the roads, and they're consuming 4 terabytes of data each per day. So there's a huge IoT problem in general with our devices that we're talking about. But aggregation from a plant floor perspective is very similar to what we're seeing in those consumer devices, where now you have everyone carrying 1, 2, 3 devices that need to be hooked up to the internet. That aggregation issue translates here into lots of material packed together in a very tight space. Being able to coordinate lots of material packed in a tight space, having them dance in a coordinated dance and get to the right places is a key goal of IoT, and it's solving it by having the devices talk to each other, having them understand their basic recipes, their material flow, so that they can anticipate actions and move without a large coordinated force. We'll call it the invisible hand of IoT. By making things smart and decentralizing the decision-making, aggregation is achieved. You're able to deal with an aggregate amount of material without having to expressly deal with each one individually. The next goal of autonomy is important. And this really goes to the same things we've been talking about. We want material to move without human intervention. IoT should be machine to machine, should be material to demand trigger. It should have an autonomy to it that allows it to make its own decisions. And that's a really important goal in many industries, whether you're talking about autonomous vehicles or cobots or material like this. There has to be an ability for you to sense your environment and make a decision on a basic level that's appropriate to your state. Maybe the next slide highlights it better. You know, many of us today are using automated GPS systems to navigate around. In fact, my kids haven't been used to maps for a long time, and I'm sure there's a generation that will not know what a paper map ever was. I think that generation's here now. But imagine if your GPS was just a data collector, like a lot of systems are today, whether you're scanning barcodes or even reading RFID tags, just collecting data. And that would tell you that you got off course, or that there was a construction project up ahead, or a huge traffic jam, but it wouldn't give you the ability to recorrect it. In other words, no recalculation. If you turned off on the wrong path, it would just note that you were on the wrong path, but wouldn't tell you how to get back on the path. How useful would that be? Not very useful, right? I mean, we've all had to drive around and change our route, and as a result, have the GPS recalculate for us. So there's a key element here of IoT that it's not just a data collection technology. It's a dynamic control technology. True industrial IoT means that the elements can react to the data and use it to optimize the process, not simply track what's going on. As a plant manager, nothing drove me crazy more than coming in at 8 o'clock the next morning and finding out the mistakes we made yesterday. I could have got something on the 4 o'clock truck if I knew then, but my tracking was only good enough to tell me what happened yesterday. And yes, I could take corrective action. I could try and train my team. I could take out inefficiencies in the process. But my dream in IoT is that I will get the message in real time, and I don't even have to do anything. The material will correct its route itself, and it will make it on the 4 o'clock truck without my human intervention. That's the goal we're talking about, and that's what all of our customers talk with us about, is how do I achieve a system that will do that. So let's talk about ProVIEW, and this is our answer to all those problems we've just highlighted. ProVIEW goes from simple track and trace to true industrial IoT control. Dynamic ability to change the process, to get material to the right place at the right time in the right state, and to give you full visibility of it. ProVIEW stands for Process View. It allows you to view your process digitally, create a digital twin of what's happening, and enable you to get full transparency down to the level. But as we mentioned, it's not just tracking, it's dynamic control. Not only are you able to see all these things in terms of the view, but you can be proactive in terms of making changes and controlling it. In fact, the devices themselves can be proactive. The system has the advantage of leaving paper behind. You no longer have to have paper printed on these items. In fact, that's a detriment. You want to have dynamic things that change faster than paper. You get two-way communication between your material and your system, enabling you not only to receive tracking information and know where things are, but to send instructions down, to tell workers to do something different. Maybe a machine is down, or maybe a truck is going to be late, and you're able to dynamically change the instructions to those pieces of material. ProVIEW is hands-free and wireless. Very, very important. We've all learned the benefit of wireless in our own personal lives. Not having to string wires across a plant is huge. Being able to move things around on wheels is huge. Being able to dynamically change the way your tooling is arranged and change your line arrangement, change your supermarket from a line to a U, very, very simply. All of that's enabled by wireless. Wireless also allows us to communicate with a lot of moving devices. Robots, AGVs, AGFs are increasingly common on the plant floors. And being able to talk wirelessly to those is the only way you can really effectively communicate. So very, very clear. Of course, over top of this, there has to be a software element. ProVIEW also is software. There's software service that runs to talk to all of these different kinds of tags and talks to all the different machines. Also talks to your back-end MES ERP system, whether it's hosted or it's premise-based. Of course, both models have to be there for the kind of market we're in. Okay, let's talk a little more detail about ProVIEW and how it works. So we mentioned smart material at the edge. ProVIEW really is all about that. It's about putting some intelligence more directly onto the material, whether that's through a small tag or a larger visual tag. We're able to create an electronic intelligence directly on the container that the material is flowing around in. And as we mentioned before, that's the key to our system. There are occasional materials that we can put an intelligent tag directly on as well, but by and large, we focus a lot on the containers. Whether these are carriers or racks or totes, those containers are the key to solving the material flow problem as they move throughout their cycle. Dynamic instructions can be sent to them. There's operator interaction, talking to the humans, and there's automation talking to the machines. That wireless signal we talked about can talk to a forklift, can talk to a robot, verifying they've got the right material in front of them and that they're doing the right thing with it. And of course, that IoT side, that you have real-time visibility, the data signals coming off of these materials and getting up into your cloud or into your premise instance is huge to give us real-time visibility. All of this happens while eliminating paper. And what does that mean? Why is it important to eliminate the paper? Well, we already explained the huge detriment it is to have a static piece of paper that travels through the whole process. Because it can't change, one of two things happens. Either you print tons of instructions on that piece of paper so that everybody all through the process has something they need to read, but it means now that any individual worker is looking at a card or a sheet of paper or a booklet that has way more than they need to know for what their job is. Or you print a minimal amount of information on it, and you expect tribal knowledge to tell people, well, based on what I see on this card, I know I'm supposed to do this, but nothing's really telling me that. I just kind of know it because I was trained that way 2 months ago. Both of those things are hugely limiting in the current environment of manufacturing. We want to be dynamic. We want to send new instructions every minute, every hour. We want to bring new workers on or new machines in contact. So paper doesn't work that way. But just walk with me through a quick cost analysis. If you take a container and you're printing something to go onto the container, an average price for that might be, say, 5 cents. It costs you. And when I say 5 cents, that's your paper, your toner, your print contract to service those printers, maybe a little bit of time for the worker to take it off of the printer and slap it onto the container, and then to take it off at the end. But a number that a lot of our customers use is 5 cents. If you're going to relabel that container a few times a day, say 3 times because it's cycling on a 4-hour shift, and you're going to do this for 265 production days a year, so a typical kind of production cycle, you're going to spend $40 a year labeling each container in your plant. $40 a year. If I could tell you that I can take that $40 you're already spending on paper and I can put a tag on it that costs less than $40, but will give you all the characteristics of paper, I can show a barcode, I can show a part number, I can show contents of the container, but I can also track it in real time. I can change that in real time to give different instructions. I can keep an as-built record, a parts history. I can do QA holds. I can have worker confirmation where they can press a button to say they did something. If I could give you that for less than $40, why would you use paper? So in the context of all of the things we're talking about, dynamic manufacturing, the ability to reconfigure lines quickly, to be able to give transparency into the plant for customers and suppliers, paper is not going to stand up in our future. And today, ProVIEW already offers an alternative that is a slam dunk, no-brainer that you should be putting on every container instead of that piece of paper, that Kanban card, or that workbook. Next slide. So the core of the system that we're talking a lot about are the e-paper tags. Now, of course, ProVIEW works not just with the e-paper tags, but works with RFID tags, with barcodes as well. But let's focus for a moment just on the view tags, which are really the heart of the system in many cases. We make multiple sizes of view tags. We show here the view 3, 4, and 10. They're denoted by the dimension across the diagonal, so a 3-inch, a 4-inch, and a 10-inch. They serve different purposes on different sizes of containers or at different workstations. But they've been built for purpose, specifically for manufacturing. They're hardened. You can drop them. You can spray them, wash them down. They're IP65. They meet mil-spec 850. So they're made to be industrial. They're also aperture-free because of the IP65. They'll stand up to a very dusty, dirty environment. They're really hybrid tags. They have an active radio at 433 megahertz or Wi-Fi in some cases, like the larger View 10. And they have a passive radio at 900 megahertz, a standard RFID Gen 2 tag embedded inside. That allows you to have one consistent system, whether you're using your Wi-Fi infrastructure or whether you're using RFID infrastructure. These tags will also work with that just like an RFID tag would or a Wi-Fi device would. They have buttons. The reason they have a button is so that you can have actions that an operator can confirm or that an operator can interact with the system. Again, you can't do that with paper. And having that button has all sorts of use in many, many different applications. We're going to show you here later on in the presentation. We also have multiple triggers. Some of the triggers might be passive RFID, going through a doorway. You could trigger the tag to say I'm going to a new place. There's an accelerometer built into every one, so we know when we're in motion and when we stop. We know if we've done a sudden drop, things like that can trigger events. We also support infrared. Sometimes infrared is very handy for bathing an area, so we can tell the tag is in a paint shop. Infrared's also very handy for things like digital signatures. You can issue a small fob to your workers and have them click with their fob, and that code can be coded to your employee number so that you can sign a document or a test, a verification, or any other thing that you're doing through your workstation. So the view tags are incredibly flexible. They've got sensors, they've got triggers built into them, and of course the ability to put up instructions that look like paper dynamically at any time in the process. And they're very, very important as a technology to help the system work well, especially where you need to do a lot of dynamic work instructor changes. A lot of people ask me why the e-paper. And just to explain a little bit, obviously one of the reasons why we have e-paper here is that it's persistent without power. That means that these batteries can last a very, very long time. The tags are built to last for 5 years under normal conditions. And so that's enabled partly because you don't need to use any power to keep the image up. I had one customer where they set the tag back where they'd run over it with a forklift, and there was actually a hole where the forklift punched right through the tag at one spot because they impaled it on the forks of the forklift. But you could still read the entire rest of the image on the screen. In fact, even with it damaged and the battery ripped right out of it, the screen stayed in the same image. So for those who would resist the technology and say, well, I like paper, paper's more secure, this is paper. You can pull the battery out, the network can go down, you can hit it, it's going to stay there as much as paper will. Of course, paper also can be destroyed, and you can burn it, and you can run over it, just as these tags can, but they'll take as much abuse as a sheet of paper will, and they'll stay just as persistent. So e-paper gives us those characteristics, reliability and low power, and that's why they're pretty exciting. You see on these view tags everything in black and white. We have a new generation of tag working through our system now that has color as well. A single color, primarily red is our stock color, but we can do green and we can do yellow or amber as well. Certainly there's a lot of investment in e-paper getting multicolored in a real dynamic way with many colors on it. Today those technologies are a little bit too expensive and unwieldy for this format, but we can see a future where eventually you can see full color. But for now they're black and white or a single flag color to make them go. But that's incredibly useful in its own right. We'll go to the next slide to explain that a little bit. As we mentioned already, it's a pretty simple tag. There's a cover on the front, which includes a button. There's an e-paper surface in the middle, and then behind you have a power source. Because we make the tag in a clamshell style with a top and a bottom like this, it means you could change the top to do different things. For instance, putting on a different company's look and feel or logo or color. It means on the bottom, if you had a different power source, say you wanted to remove the battery and do something specific for an application, you could do that as well, or put a bigger battery in and have a bigger back case. So we have a lot of flexibility to do some customization here to make this work. We have highly responsive communication. We can talk these tags within a 3-second window at any given time. And with the range that these tags can be read, that gives you a very large zone of coverage. You can't drive a forklift fast enough to get outside of the zone of coverage in 3 seconds. So we'll always be able to see the tags at that kind of a beacon rate and communication rate. There's an integrated button. In fact, we have different button options here to give you different tactile performance. And there's also an LED that can flash. You can have control of the LED from a distance, or you can program it to react to different status changes or button presses to be part of your process. An important part here is the expansion port on the back. The back of the tag has a small 4-pin header that can be exposed by removing a sticker, a sealed sticker on the back. That 4-pin expansion header allows you to put extra things like a mechanical switch, a big clown nose button, a light stack, something that you want to flag in your process. That's a really handy accessory port that many of our customers use in many different ways. So anything that can toggle a pin or be toggled by a pin, because we can do output and input on those 4 pins, are possible through the tag, creating a true IoT solution that can communicate with many different things. And I mentioned before that there's an accelerometer there for motion detection, which is very helpful when you want to know if your goods have stopped or started or understand their path of travel. So I mentioned software, and important that you understand the software here. Our software architecture is built upon some common Windows-based mechanisms. So the first thing you need to know is that we are Windows-based, Microsoft.NET, C# built. HTML5 is the front end for all the UI pieces. So it'll be very familiar to many of you, very modern architecture in terms of what we do. We have an interface at the bottom. You see the Omni-ID hardware interface, or what we call the HDK, the hardware development kit that we give out. That's an open interface that's documented and available for you to develop on. For some applications, especially in alternative industries, like healthcare is a prime example, they will want to use these pieces of hardware, these view tags, and other pieces of our lineup, but they don't necessarily need our specific manufacturing applications. That's fantastic. We're happy to open up that API, and other applications can be mounted on top of it through simple Windows-based function calls that are there. We have a RESTful API as well as a DLL-style API that can interface with your application. But we also offer in our server a number of services. We have a business logic engine. We have a message and event bus that allows us to handle different queues coming from the hardware layer. We have a location services module. And of course, lots of user admin, LDAP, user authentication type things going on in the services layer. those services are shared between all the applications we mount over top. And of course, we manage database, which is SQL-based. Again, very common and a great way to talk to your data. That database can be our database, or it can be written to a database of our customer through our data services layer. The 5 applications that we are talking about here, replenishment, work instructions, picking, container management, and asset tracking, are all applications mounted on top of those common services and can all work together to achieve that material flow goal. While we've carved these applications out so they can be a little bit more specific to their use, they really are all about a full comprehensive material flow application. And most of our customers use most of these applications at the same time, whether 3 or 4 of the 5 would be commonly deployed at the same time and talking to each other. Over top of the application layer, you see the Omni-ID ProVIEW API. That ProVIEW API is key for other systems to talk to our system. So if we're doing replenishment or we're doing picking and we need to talk to the warehouse, there might be a WMS that's running that needs to communicate directly with ProVIEW. It would work through that API. And that would be using RESTful methods, JSON specifically, exchanging data through XML files, and being able to then talk to our applications with their applications. So we've done implementations very quickly, hooking those up, a couple of weeks between, say, an MES or a WMS and our system. Some take a little longer, depending on how specific and how many calls we want to implement across that RESTful API. But it is an open API, documented and available for a third-party application to talk directly to the ProVIEW apps. Very common that we talk to MES and ERP, as I mentioned before, and also common that we talk to various mobile clients. Tablets, cell phones, smart devices will all talk through that ProVIEW API if they're a native app, or more commonly, there'll be an HTML5 browser that's running on the device and displaying some of the apps specifically in that environment, and they'll be resized to fit that screen. So it gives you a little overview of what the software looks like. To get a little more detail of what each of the applications do, Pick is really about taking all the different parts and picking them into kits, whether they're sequenced kits or whether they're just being picked directly into bulk picks. ProVIEW expedites that. It's the ability to put the visual instruction for the picker and to guide them, and I'll go into that in a little bit more detail. Container management or smart container allows us to track all those materials within their containers in aggregate, knowing the container contents, the container state, the container location. Put dots on a map if you're looking for a particular kit or container. So that's a really important app and one of our most popular and pervasive apps with our manufacturing clients. Work instructions replaces the paper, whether it's the build books, the build manifest, or a traveler that goes along with materials. Work instructions allows you to display those instructions directly on the device if it's an e-paper device, or on a tablet if you've got a tablet there, or on a standing screening. It's really about displaying instructions at the right place when materials arrive, and the software enables that through different triggers telling where the material is, and displaying the right formatted work instructions through templates. Replenishment is about signaling warehouse workers or supermarket workers to bring material to the right location. Sources and destinations are encoded. Routes are developed so that you can have different workers service different routes, being able to bring material from one place to the next and monitor that material flow. So I think very common applications. Any of you on the call that are manufacturing folks, you'll recognize that you have all of these happening in your factory, and we are servicing them with specific built-to-use applications with good user interfaces and dashboards that allow your workers to get these things done. But in total, it allows us to cover 90% of the material flow applications in your plant. And by cobbling these together in different ways and different combinations with different underlying technologies, we're able to give you full transparency and visibility to all of your material flow. So a quick couple of detailed slides to go a little bit more further and give you some graphics. Pick. So what's the key to a ProVIEW pick? Well, jobs are sent to ProVIEW, so we'll have an MES system that's telling us we need to pick job number 5, and that job will have a parts list. We'll have associated a view tag with the part. So how does that happen? Well, when you first set up your supermarket or your warehouse, you might have a bunch of bins with material in it. You'll want to associate one of these view tags with that particular piece of material. A common way we do it is through barcode scanning. The face of the tag will have a barcode scan that has the MAC ID of the tag, and the part that's sitting in the shelf will have a label attached to it with a barcode label. By doing a scan-scan association with a simple barcode scanner, ProVIEW will know that that part is now represented by that visual tag, and you can stick the tag on the shelf edge. We have brackets that you can snap it into. Many of our customers just put Velcro tape, industrial Velcro tape on the back, and just Velcro it up to the shelf. The advantage to that, of course, is that parts move all the time. You decide you want to represent different parts in your supermarket. You want to reconfigure your supermarket. With a Velcro or a simple snap bracket, you can snap and unsnap these different tags and move them around as you wish. Completely wireless and completely configurable within the system automatically. So really superior to a lot of the hardwired picking systems that are out there today. So once we have the job is sent down to a device. In this case, you see on the screen a little tablet that's mounted at the edge of the pick aisle. That's showing all the pick jobs are being picked in that zone right now, and the worker is able to scroll through them. In some customers, they allow the worker to pick which job they're going to do next. In other systems, they don't. They just tell the worker you're picking the next one in line, and the tablet's telling him that. But either way, we can send to a tablet or a workstation the total pick list. We can monitor which jobs are being done. We can back up and repick a job. All those things happen at that place. Once you pick a job, ProVIEW then lights up the tags that are part of that job pick, either lighting them up in batch mode or lighting them up sequentially if you're going to do a wave pick. Both are possible and configurable within the software. So the image will change. You see the image down the bottom right. What commonly happens today is that the tag stays in a black on white background when it's at rest, and when it's doing an active pick job, it changes to a white on black. That inversion is easy to see looking down the line. It's as easy as a light lighting up, but it doesn't take any power. As we mentioned before, being e-paper, they're not drawing power to keep the image. That means that these batteries can last a very long time, many, many years, even in a high-speed pick environment. So typically the tag inverts. That tells the worker which part to pick. He goes to the tag that's black. He picks the part. But not only can I pick the part, the tag can give me instructions. It can tell me to pick 3 instead of 1. It can tell me when I pick it, I should put it into a particular slot or order it on a pick cart. Many of our customers have a cart that's going through along, and the cart has different bins or shelves on it, and parts have to be picked specifically different bins or shelves on that pick cart to get them sequenced as a kit. And so instructions can be displayed, not just pick me. It can say pick me and put me here, or pick 4 of me. And that's really important. The other thing that's important is the action confirmation. We support a button press so that the worker can press to close off the pick, say, yes, I picked the part. It's very common to have our worker pick it and slap the button on his way by to say, I picked it. The accessory port I mentioned on the back is really important here. With the accessory port, we can add bigger buttons to make it easier. We can add sensors that would automatically sense his hand reaching into the bin. We can add a weigh scale or a load cell that tells us that the bin is getting empty. There's a lot of extra things that we can do here that are fascinating and fun in a lot of the apps we've done for customers using that accessory port. And we also confirm actions through the tablet that I mentioned before. That tablet list has a UI that allows you to go ahead and close the pick job, say, yes, I got it all, or no, I didn't, I have to go back and pick another part. So that action confirmation is an important part of the process. When we talk about visualization and analytics, remember I talked about the transparent factory, people wanting to know what's happening at any given time? Having the confirmation allows you to time different actions. How long did it take to pick a given job? Does one job take longer than the other? Is one part being picked more often than the other? Should I move it to the front of the supermarket to save time? All those kinds of analytics are enabled by the data that's collected through ProVIEW and through that action confirmation and the visual cues that are happening for workers. I should mention on Pick, another big strong selling point here is that it's so simple to use, there's no training time. One of our customers has a lot of temporary labor coming in, a lot of turnover, and they used to have to take days to train workers to get them to a reliable pick rate without errors. With the ProVIEW system, they found they could have them productive in a couple of hours because it was so intuitive and simple. And again, visual cues are the most effective for instructing workers. We pick up most of our learning through visual means, and so it is a very important operation and key foundational principle of ProVIEW. Next application is replenishment. It's often related to picking. And in fact, we integrate replenishment in picking. So you could be picking from the front face, and you could be replenishing material to the back face of a supermarket like you're seeing in the picture at right. Commonly, we trigger a replenishment call. That call can be triggered by the operator who's looking at the visual tag, looking at the parts, seeing that they're empty, and you could press a button to say, call for more parts. That's very common. Sometimes we use the accessory port on the back where it could be triggered by a switch or a sensor to say that we're out of parts and we need to go get some more parts. Or it could be integrated with other applications where another app needs parts and hence it needs to be replenished. So there's lots of different ways that those happen to ProVIEW, but the job gets sent to ProVIEW. A replenishment operator gets a ticket. This is an electronic ticket, not a paper ticket, but the electronic ticket will show up on their dashboard. There's a driver dashboard and a warehouse dashboard. Those tickets will pop up immediately as soon as the operator presses that button or the switch gets fired or something happens. And the warehouse worker sees that he's got something he has to service. A threshold or an alarm can be configured so that you're giving them a certain number of minutes to be able to service that ticket. If it doesn't get serviced, you can turn it to a different color like yellow or orange to say that you're in jeopardy of slowing down the line and you need to get on this ticket right away. The tickets can move up in priority on your dashboard so that the urgent ones start to come up to the top and they know they have to service it. And then, of course, it can go red when it exceeds the threshold, even signaling another worker to take over or signaling a manager that there's a problem and that they need to get over there and get that ticket done. So these tickets are a key part of managing that. Drivers and tug drivers, pull cart drivers can look at that dashboard on an intelligent tablet that might be mounted in their machine or their vehicle or on the edge of their cart, and then they can confirm that they've gone and done the ticket and closed the ticket out when they deliver it to the line. The ticket can also be closed automatically if the material is delivered to an intelligent line where there might be a sensor there already, or auto-track through location services where we can locate and see the material moving from a warehouse to a line side, and we can close the ticket automatically that way too. So Replenishment is a very handy app, saves a lot of time and a lot of labor. Next slide on work instructions. This is pretty intuitive for everyone. We show the instructions to workers in process. Our e-labels are very important for that. It allows us to show that. As-built records are built as we do that, so we can see the full material history. And there's a lot of great QA functions that are enabled here. You can quarantine parts. You can signal remedial actions, telling a worker exactly what to do. And you can do test parameters and add digital signatures to your documents electronically as they go through. So Work Instructions is a cool app for all those reasons. And lastly, container management. We mentioned before that smart containers are the key to IoT. Making those containers location aware and recipe aware. I mean, recipe means that when you start a container on its journey, you know it has to go through 5 or 6 steps before it can get on the truck. And those steps can be encoded in your process using the container management application. So the material can become aware that it hasn't gone to step 2 yet, so it can't go to step 3, and it can signal different machines and humans that it's in the wrong place or in the wrong order. By its location, it can know what it should be displaying in terms of instructions. It can be signaling the cobot or the AGF what to do with it. And it can give real-time feedback to its process owner, the MES system or the material flow system that it's in. So smart containers talk to machines and humans, giving them real-time instructions, real-time location, and real-time state, where am I in my recipe at any given time. And that is a powerful paradigm, which I'll let sink in. And we don't have any more time to talk about it on this webinar, but having those containers become smart is a real key to making your material flow more efficient. If you've got a plant that does $1 billion in transformation like one of my plant customers does, and if you can save 10% on your inventory levels just because you're able to use the smart container application, that's a lot of money, a lot of cash flow. And so there's a significant savings here by going through this paradigm change. Next slide. So I just want to remind you again, our vertical focus at the top of that pyramid on the left-hand side, or that column, is professional services and support. You need to know that Omni-ID has built significant expertise in helping you implement these systems and understanding your material flow. If we flick to the next slide to talk about a customer specifically, we do consultative engagements. This success story was with a Tier 1 automotive manufacturer. They had a problem with their pick and replenishment. They asked us to come in and work with their continuous improvement team to figure out how to make it more efficient. We actually engaged in that, in doing some of the measurements, the time studies, understanding how the system can be improved, and doing a first install to pilot the concept and build the value proposition. Once we gathered data and assessed it, we had the clear savings quantified. We became a corporate standard, and we're in the midst of that rollout going to multiple plants. So if you're concerned that you're maybe not on top of IoT, maybe you're not sure how to apply these new technologies to your line, we can certainly work with you, as we did with this Tier 1 manufacturer, to be able to bring IoT into reality for you. It's not that scary, but we have seasoned professionals that have been plant managers, that have worked in manufacturing all their lives, that can guide you through this process and apply this new technology. This was a great success for us and continues to be a great relationship going forward. Next slide highlights something similar. This would be a replenishment application. Remember, we talked about things on wheels? This Daimler plant has a lot of their material on wheels, and these carts were able to be mounted with a wireless view tag to be able to give instructions to the replenishment workers to pull things around. So track the material, allowed us to bring things line side and do the appropriate triggers to make sure we never ran out. We reduced a lot of paper, won some Green Initiative awards. We increased the line up time and reduced cost with the direct instruction, really repurposed some of the labor that didn't have to spend time sharking or patrolling the line, and generated some great real-time whip information. So a great success, and we continue to do some more things with Daimler around the world as a result. Next slide. Similarly, in Daimler, I wanted to highlight an application with work instructions. They had a large build book that they were using to control the build of engines. The build book would be anywhere from 40 to 60 pages. Burned a lot of paper and was very cumbersome to work through and to mark up with big markers and crayons that they used at different workstations. We replaced that build book with the electronic tag, eliminating all the cost of all that paper, but creating as-built work instructions, the ability to mark things up as they went through. So a great success story that we're repeating again in multiple plants for that customer. On container management, maybe a good example is a large chemical manufacturer we're working with. Containers are going through a process where the stages are key. They're key because you need to know that you went through the stages in the right order and doing quality at each of the stages, but also look at aging. Some of these chemicals, of course, have shelf lives and even can be hazardous if they're allowed to build up in a certain area or a certain stage. So the instructions for the workers vary based on the state of the process. So we integrated ProVIEW with their ERP system. So the ERP had a constant view of the process. There was full transparency for their customers. In many cases, customer orders were overlaid into this system so the customer could know where their order was at any given time. For them, they also have a lot of compliance issues, as you can imagine, and even undergo a lot of customer audits to make sure material is handled correctly, if they have to do traceability back through the system. So the data records produced are also very, very key in this application. But a great success, and again, a multi-plant rollout we're doing now with that particular customer. So in conclusion, this is real. I hope that this webinar has shown you that IoT is here and it's practical today. It's not just a concept. Using visual signaling, visual tagging allows you to get a handle on your material flow and really change the paradigm for manufacturing today. If you're not using ProVIEW or looking at something like ProVIEW to be able to change your plant floor, you're still back in the 70s with a number of other companies, and it's time for you to have a look at using new technologies to automate these process flows and save you a lot of money and allow you the flexibility that's required. So we're going to take some questions. I know we've got a number of questions that are up here already as they've been coming in. So let's go through a couple of these things. One question I have is, what is the administrative burden to ensure the right tags are linked with the right workflow or data, especially in dynamic environments with frequent tag recycling? And that's a great question. I mentioned earlier that, of course, you always have to have some association between the material and the tag. How that association happens is a great question. Primarily today, it would happen with a cycle association. So in other words, if you have one container that only holds one kind of part, it's very simple. That tag will always represent that part. And it's just about which batch of parts was loaded into a given workstation. ProVIEW can do that automatically by pulling that machine trigger and loading the container with that. So there's no user intervention. If that container is used for multiple parts and you reload it with a different part every time, the only way to know which part is in there at a given time is through a manual association. Probably a barcode scan, where a worker might scan a simple barcode label of the material, scan the barcode label on the view tag, and now those two are associated. That could be automated sometimes with an in-place fixed scanner that might be able to present it. Certainly, if there was RFID tags on all the material, it could be automated and we could associate them together. But yeah, you do have to pay attention to the association steps, and I think that's a very insightful question from one of our attendees here. Another question was, has Omni-ID's platform been integrated with SAP? SAP for sure is one of the most dominant packages that we encounter almost everywhere we go. we've done a number of SAP projects, and we use iDocs. We do a number of key interfaces to talk to different versions of SAP. I know Quattro and Fiori are two common packages that we've talked to. So yes, the answer is yes, and we have a professional services group that allows us to create new drivers for new applications all the time. But the hooks are there to talk to any ERP system that we have. Third, has this solution been used in laboratory environments or pharma, bio, for different things? We don't have any specific certifications with ProVIEW yet for FDA, for instance, or even some of the military-grade certifications. So today, ProVIEW is an application that has been certified through good practices and through our Microsoft development, but not through any particular industry standard. Okay. Now, one of the questions also talks about, will ProVIEW run on any mobile device? I mentioned that a little bit in one of the slides, so just to go over it again, ProVIEW doesn't require a specific app to be installed on your phone or your tablet. It is using the HTML5 browser on your device, and so we can use that browser technology to display a client on your mobile device. So that's really the way that it works. But as a result, it'll run on any HTML5 compliant device, anything that has a browser that can run HTML5. Related to that, another question is about the cloud. Can ProVIEW run on cloud? Today, of course, the service can be hosted as a virtual machine on its own server, whether it's hosted on the private cloud or on a public cloud. The challenge is that we are moving our architecture to more of a cloud-based, inherent cloud-based architecture. That is, that it's going to grab resources dynamically as it needs to expand and expand across your enterprise with some of the lovely hooks that are there. So I guess I'll answer that question as we are running on cloud, both private and public for some customers, but there is a little bit more work to do to be a true cloud application that we're working on as we build out ProVIEW over time. Only got a few more minutes. Let me grab a few more questions. We talked a lot about plant floor. One of the questions talks about, can you manage through different tier suppliers outside the four walls of the factory? Certainly, that's what we were designed to do. In fact, picture this in your mind. What would happen if you twinned two ProVIEW tags? One ProVIEw tag is at your tier 1 supplier, and the other's on your main line. And as the tag runs out of parts or is finishing off a build, if immediately the signal goes across the street to your tier 1, telling them that I need to replenish that particular good. And you use ProVIEW Replenishment to pull that across and get that package in transit and get it delivered line side. That's the vision that ProVIEW has. And we have at least one customer where we have an integrated tier 1 and manufacturing line doing real-time parts delivery directly from the tier 1. So there's no issue having different instances of ProVIEW in different buildings, distributed anywhere in the world, and using the internet as the common backbone to talk to the two instances. To be able to send these material signals and visibility across the web is exactly what it was architected to do. And we do anticipate, that group of tiers to be able to supply. How long do the batteries last is one of the questions. I think I mentioned in one of the earlier slides that they're a 5-year battery life. That can vary a little bit up or a little bit down depending on the use, but the main design is for typical use to last for about 5 years. And another question, how much RF infrastructure I need to cover my plant? If it's the case of passive RFID Gen 2 or if it's Wi-Fi, some of our tags will work with those existing systems already, and you might not need any extra infrastructure. You may already have some things installed. If you need to install the 433 backbone that we've got, you've got to think about one antenna or one station kind of covering about 350 to 500 feet in radius. So it covers quite a large area. And you'd have to put one of those up every, say, 400 feet. So think about that as your zone of coverage if you want to have contiguous coverage everywhere. More often than not, we create islands of coverage with our customers where we're illuminating a dock, we're illuminating a couple of workstations, we're illuminating a line. And so a typical install might have only 8 to 10 total reader stations, or what we call gateways, a device with an antenna that can irradiate an area, even in a very large facility. The Daimler example we showed you here, we only used 3 of those gateways to cover their entire area. And so it really isn't a big installation burden to cover the plant. We're really getting down to end of time here. Tracy, how long do I have? Till the top of the hour?
Top of the hour.
That's what I thought. Okay. So what's the timing in months and years that you are seeing for ROI for these types of projects? That's a great question. Thank you for asking that. I spend a lot of time on this, as you can imagine, as I meet with different teams at our customer side. 12 to 18 months is the typical guidance I give. We have certainly had projects that have had ROI of 6 months. In fact, I just closed a project that was a 9-month ROI. So we certainly do better than that depending on the situation. But a good rule of thumb is this is a 12 to 18-month ROI. Now, in saying that, there's a lot of factors that we believe are very important that aren't being thrown into the ROI calculation typically by our customers. And you can appreciate that. Efficiency savings, quality improvements, pick quality improvements, for instance, when we talk about picking. These are intangibles that often don't get measured in the calculation. But strict labor savings, paper savings, things that can be quantified, we usually are in a 12 to 18-month ROI. What's the training for operators? What's the learning curve? I mentioned how intuitive it is. Because it's visual, it's very simple, but of course, everything takes a learning curve. So one of the examples we gave here, we went through the project to do the initial installation and training of the people in the first plant. We're now rolling into the 7th and 8th plant this month, actually, and we're not even touching the plants anymore. They're installing it themselves and training their own people without us even coming on site. They used to configure a supermarket in about 10 days, and now they're configuring the supermarket in about 2 hours. Really an improvement based on the technology being so intuitive and easy. So nothing's for free. You have to learn the system. But once you've learned the system over the period of a single install, which might have a week's worth of training and on-site work together with you, or 2 weeks, you'll be able to roll it out and reconfigure it yourself in minutes and hours, not weeks and years. Okay, I think we need to close. Thank you so much for spending the time you have with us. I know it's a valuable hour of your day in your life. I hope it's given you some thoughts about IoT and how it applies to manufacturing, and certainly given you some insight into what Omni-ID's role is in automating the next generation of manufacturing. Please call us. My number's here on the board, but also, of course, through our website. There's a number of email addresses you can ping for more information. We have an excellent group of professional sales folks all over the world that can come and see you and walk you through this and help you with these applications. We look forward to hearing from you. Look forward to working with you.